So, hey, good morning, guys. So, last time we started working with stoichiometry. So, again, guys, when we talk about stoichiometry, we're looking at the relationship between the relative quantities of substances in a chemical reaction. So, basically, guys, what you're looking at is the proportion, okay, between the compounds, the reactants and the products within a chemical reaction. So, essentially, what you're looking at is you're looking at what you call the coefficients. All right. So that's why the last time we were here, we looked at what you call the mole ratio. And again, so in a chemical reaction, what you're looking at is the compounds, right? The quantitative relationship, which means we're looking at coefficients. So when you say, what is the mole ratio between Fe and O2? We're looking at the coefficients, okay, for Fe and O2 in the chemical equation itself. So look at Fe. Fe is right there. You see it? So 4Fe. So this 4Fe is actually read as 4 moles of Fe. Okay. Remember, guys, this can also be read as 4 molecules of Fe, but for stoichiometric problems, we just read it as 4 moles of Fe. You got it? All right. And how about the other compound, O2? So in a stoichiometric problem, most of the time, guys, we're just looking at two compounds within the chemical reaction. So again, so it's like, looking at the relationship between a boy and a girl, man and a woman, father and son. So we're just looking at two things within the chemical compound. So this would be 3 moles of O2 right there. Okay. This is your mole ratio right here. This is the mole ratio itself. And remember, guys, if you look closely at this one, this looks very, very familiar. We can use this as a conversion factor when we do stoichiometric problems like we did last week. All right. But before we go back and look at that, let's introduce something new. Let's look at this flowchart right here. Okay. Because when we did those these problems right here last week, a lot of people ask, uh, why haven't we used the strategy before where we had one mole at the bottom and then the molar mass on one side? So how come it's not that? Okay. All right. Actually, we're going to still use that, but first of all, we have to look at this flowchart right here. Okay. So how will we use flowcharts, this flowchart, guys, to tell us exactly how we're going to solve a stoichiometric problem? So again, let's start. So if you look closely, guys, at our flowchart, the boxes at the top are for the given. So for example, if you're given our molecules, this is where you start. Okay. If you're given as moles, this is the box where you start. Okay. If you're given as in grams, this is the box where you start off with. Okay. Now, if you look closely, the bottom boxes are for the unknowns. All right. So if you're unknown and what you're looking for, okay, that's what the unknown is. If what you're looking for are molecules, you have to end up with this box. All right. If you're unknown, what you're looking for is moles, you have to use this box. Okay. And if your unknown is grams, you have to use this box right here. All right. So you have to start with one box at the top and end up with one of the boxes at the bottom. So because you have to start with the given always and end up with the unknown. All right. So if you look closely, guys, between those boxes are arrows. The arrows, for example, this one right here tells you exactly what is the step that you're going to take. Or in our case, it's going to show you exactly the conversion factor that you need to solve the problem. All right. Okay, so if you look closely, the maximum number of steps that you can have if you use this flowchart is 3 steps. All right. So let's get straight to business and let's look at our previous problem from last week and try to solve it using our flowchart. All right. So let's say you weren't here last week, okay? And I said this problem right here is you have to show the boxes in the squares method to show how to solve this problem. All right. So let's read the problem. So first of all, you need a balanced chemical equation. All right. So there you go. There's a balanced chemical equation right there. Okay, 4Fe plus 3O2 gives you 2Fe2O3. The question is, how many moles of Fe2O3 is formed if 1.5 moles of Fe is used up? All right, so the first thing you always do when you have a stoichiometric problem is write down the given. What the heck is the given in the problem? Oops. So what is the given in the problem? All right. So our given, if you read closely, guys, the given is always the one with the number inside the problem. In our case, it's 1.5 moles of Fe. All right. So what we're given is moles of Fe. So if you look at your flow chart, which box would you start with? Box number 1, box number 2, or box number 3? Okay. If you read closely, the given is moles. So you have to look for the box that says given moles. Therefore, you're going to say, oh, we have to start at box 2. All right, that's good. And that's going to be your starting point. Okay, so again, box 2 will be our starting point. See it? All right. Now we need to figure out what are we solving for? What is the unknown? Most of the time in problems like these, you have to look for keywords like how many, what is, all right? So in our case, it's the how many what. So the unknown, if you read closely, it's asking you for how many moles of Fe2O3, all right? Fe2O3. So again, the unknown is moles of Fe2O3. So this time, guys, we have to look at the bottom boxes, the last row, because those boxes are for your unknown. So which box do we end up with? Is it box A that says unknown molecules, particles, or atoms? Box B that says unknown moles? Or is it box C that says unknown grams? All right. So if you say we have to end up with box B, you're right, because it says there unknown moles, and that's what we're trying to solve for, the unknown moles. All right, so that's your endpoint. All right, look at those two boxes. So going from start to end, how many arrows do you have to go through? We only go through one arrow, this arrow. All right, and what does it say? It says there you need the mole ratio, which is the coefficients from the chemical equation. So I need to look at the chemical equation and find those coefficients. So how do you know? There's three of them: 4Fe, 3O2, 2Fe2O3. How do you know which two? Remember, you only need two. How do you know which two do you need? You have to look at your given. So what's your given? Fe. So I need to get that Fe, and that is 4 moles of Fe. And I need Fe2O3, which is this. This is 2 moles of Fe2O3. So this is your mole ratio. All right, so that's your mole ratio, and that's the conversion factor that we need to solve this problem. All right, so are we done? No. Remember, guys, to solve this problem, you actually have to set it up using the boxes and squares method. All right, the dimensional analysis. We should still remember how to do that. First of all, let's draw our quadrants, right? Remember, in the bottom left, the first bottom left box, there's nothing there. And on top of it goes your given. So if you look closely at our given, it's 1.5 moles of Fe. All right. Now, since we only have one step, so if you look closely again at our flow chart, we only have one step, and that's the mole ratio. We just need those next two boxes, and that's it. So we have to put the mole ratio in there. All right. So we have 4 moles of Fe and 2 moles of Fe2O3. The question now is who would go on top and who would go at the bottom? All right. Think about it. So if you said 4 moles of Fe goes at the bottom, you are right. Why would 4 moles of Fe go at the bottom? Because remember, guys, boxes across from one another diagonally should have the same unit. So again, boxes diagonally across from one another should have the same unit. Okay, so that means our 2 moles of Fe2O3 should go at the top. All right, since we only have one step, We're done. We just need to figure out which units cancel out. We got mole Fe canceling out with mole Fe down here. That's it. That's the only ones that cancel out. All right. Now I need to multiply the boxes at the top. So multiply those numbers. 1.5 times 2, I get 3. And then I have to write down whatever's left behind. The unit is mole Fe2O3. All right. That's the top. We do exactly the same thing for all the boxes at the bottom, but there's only one thing there, and it's a 4. So it's just going to be over 4. Right. Now you can divide those numbers. So 3 divided by 4 is 0.75. Okay. And the final answer is mole Fe2O3. And that's the answer right there. You see it? So again, looking at this example, you should have learned that number one, the boxes on the first row, on the top row of the flowchart, is for the given. Okay, so you look for your given there. Okay, the boxes at the second row or the bottom row is for the unknowns, and you look for your unknown there. Right. So the given box will be your starting point, and then the unknown box will be your end point. Now, to get from start to end, all right, you have to pass through arrows. All right. And the number of arrows that you pass through is the number of conversion factors that you need, or number of steps that you need. Okay. And it clearly tells you within that arrow what you need. All right. For example, here we only needed the mole ratio. All right. Okay. And then you have to know which one goes on the top and which one goes at the bottom for the mole ratio. All right. Shortcut, guys, is this. For the mole ratio, the unknown formula always goes on top. Okay. And the given formula always goes at the bottom. So again, the unknown formula always goes on top. Given formula always goes at the bottom. So look, what's our given? Fe. That's why Fe is at the bottom. You see it? All right. Let's try another problem, but this time let's try to use the other arrows within the flowchart, right? So let's try that again. Let's try it again. All right, let's try another problem. For example, let's say the question was how many moles of Fe2O3 is formed if 55.8 grams of Fe is used up. So this time, guys, we have grams. All right, so let's write that down. So first of all, as always, look for your given. Okay, look for your given. All right. And if you look closely again, the given is the number inside the problem. So it's 55.8 grams of Fe. All right, let's stop here. All right. I'll give you a hint, guys. Whenever you see the word grams, okay. So again, the hint is if ever you see the word grams, okay, you have to find the molar mass. Okay. Find the molar mass. Get that? So again, whenever you see the word grams, you have to find the molar mass. Molar mass of who? Whatever formula follows the word grams. So in our case, it's grams of Fe or iron. Therefore, I need to find the molar mass of Fe or iron. All right. And I know for a fact you can do this. All right. All right. So you can do this. Since Fe, there's only one atom Fe. Look at the periodic table times the atomic mass, which is 55.84, right? 55.84, you get 55.84. All right. But since, guys, I know for a fact, all right, since I know for a fact that you know how to calculate the molar mass, you can actually just go look up the book value for the molar mass. So again, one more time, all right? If you ever see the word grams, you have to get the molar mass, okay, in molar mass of who? Whatever compound follows the word grams. In our case, it's Fe. All right. So Let's ask Google. Hey Google, what's the molar mass of Fe?
The atomic mass of iron is 55.84 atomic mass units.
Okay, so let's just stop at 8, right? So this is 55.8, and this is grams of Fe. And remember, guys, this is equivalent to 1 mole. So again, the molar mass is always equivalent to 1 mole. So one more time, all right? If you find the word grams within the problem, you have to solve for the molar mass. And again, whose molar mass? Whatever formula follows that word grams. All right. So let's look at our flow chart. So our given this time is 55.8 grams of Fe. So let's look at our flow chart. Okay. Again, you look at the top row first. So looking at the top row, the given is grams. You should know that your starting point should be this box right here. So again, the starting point will be the given grams. So I need to start right there. You see it? So I'm going to be starting right there. Again, the given is grams, right? 55.8 grams. That's why you're starting at given grams. All right. Look at the problem again and find your unknown. Again, you look for keywords that tell you that's the unknown. In our case, our unknown is moles of Fe2O3. So again, it's moles of Fe2O3. All right. So now let's go consult our flow chart. Again, it says there our unknown is moles. So where is that? It's this box right here. It's in the middle, and that's going to be our endpoint. Okay, you see it? All right. So look at the flow chart. From start to end, how many arrows do we have to go through? All right. So the first arrow tells us that we have to go through here first. Okay. Followed by this arrow. Remember, guys, they have to go in order. So this will be our first conversion factor. This will be our second conversion factor. Got it? It has to be in order. All right. So let's start writing down the solution for this one. So again, the first thing you need to do is draw those boxes in squares. So draw the boxes in squares. Draw the quadrants. There's nothing in the first bottom box. There's nothing here. And the given goes in the very first top box, which is 55.8 grams of Fe. You see it? All right. So we're done with the given. You should know, again, guys, that the first top box is always the given in the problem. Okay, let's consult our flow chart for the first solution for this one. So we need to look for the first conversion factor, the first one. What does it say? It says there at the very top. Y'all look at it. It says there I have to write down 1 mole at the top. Look at the arrow. Look at this arrow right here. This arrow, the first one, the first step. Okay, so again, look at this arrow and look at what's inside because it tells you exactly what to put as your conversion factor. It says there 1 mole goes on the top. So I put in 1 mole. 1 mole of what? Since this is the given, it's Fe. All right. Okay, what goes at the bottom? Read closely. It says there molar mass of given. So if you're reading closely here, it says there the molar mass of the given. All right, so look at your molar mass and you got 55.8 grams of Fe. You see that? And that is your first step, first conversion factor. Right. So first conversion factor, we're good. Okay. Now we need to look at our second conversion factor because there's two. Remember, there's two of them. So this time I have to add more boxes. So let me add more boxes first. And this will be our second. Okay. This will be our second conversion factor. So let's look at our second conversion factor. What does it say? On the second conversion factor, it says there I need the mole ratio. Again, it says there coefficients from the chemical equation. All right. So how do I know again which is the ones that I need? Okay, again, you have to look at your given and unknown. The given is Fe. Therefore, I need my 4 moles of Fe. Right. Our unknown is Fe2O3. Therefore, I need my 2 moles of Fe2O3. Again, that's your mole ratio right there. You see it? That's your mole ratio right there. So again, we have to put that in the next two boxes. Okay. Question again, which one goes on top and which one goes at the bottom? You have to look at it. So again, guys, it's always the unknown formula that goes on top, and the given formula always goes at the bottom. All right. Or you can use our idea before that boxes across one another should more or less have the same unit. So if this is mole Fe, box across it should also be mole Fe. Okay, diagonally across. All right. So after thinking about it, you should know now that the 4 mole Fe goes at the bottom. Okay. And then the 2 moles of Fe2O3 goes at the very top. All right. Okay. So step 2 done. Check. Right. Since there's only 2 steps in this problem, we are done setting it up. Okay. We're done setting it up. All right. So what happens now is we have to cancel out units from the top and at the bottom. All right. I'll give you a hint. Everything will cancel out except for the very last top box. Okay. Everything should cancel out except for the very last top box. So let's start. The grams Fe here cancel with grams Fe here. Mole Fe here cancels with the mole Fe here. And that's it. All right. Now what? Same as always, you have to multiply all the boxes at the top first. So multiply 55.8 times 1 times 2. Okay, so we need to multiply that. And what do we get? Hey Google, 55.8 times 1 times 2.
55.8 times 1 times 2 is 111.6.
Okay, it's 111.6. And then the unit will be whatever's left behind, the last top box, Fe2O3 over. This time I have to multiply everything at the bottom, which is 55.8 and 4. So, hey Google, 55.8 times 4.
55.8 times 4 is 223.2.
0.2. All right. I'm almost done. So now I just need to divide those two numbers. 111.6 divided by 223.2 should give us 0.5. And this will be the unit mole Fe2O3. That's basically the answer right there. You see it? All right. So for this example, what should you have learned? The first thing is, if you ever see the word grams, okay, again, if you ever see the word grams, you have to calculate for the molar mass. And again, molar mass of who? Of the formula that follows the word grams. Don't forget that. All right. Next, the next thing you should have learned from this example is the number of steps, okay, the number of conversion factors, if you have more than one, has to be in order. Again, the conversion factors, if you have more than one, has to be written down in order. All right. It has to be written down in order. You got it? All right. So someone's asking, do we need to write down the first and the second? No, you don't have to. All right. I'm just labeling which conversion factors I'm doing at that point in time. Okay. All right. Let's do one more example. So again, look closely here, right? So here we started here in this box right here on the very top left. Okay, right here. And we ended up down second row middle. See it? All right. Let's compare this with our next problem, right? Let's compare it with our next problem. All right. So look at this problem right here. Let's uh let's look at this problem right here. Okay. The question is, How many grams of Fe is needed if 2.5 moles of O2 is used up? All right, same as always. Find your given. The given is super important, so find that given. Okay, and again, the given is always the number in the problem. So again, in our case, it's 2.5 moles of O2. All right, so let's look at our flow chart. Again, the given is moles, therefore let's consult our flow chart. The given moles is right here, and that's going to be our starting point. Okay. Remember in the last problem, we started here. Okay. Because the given was grams. This time the given is moles. That's why we're starting right there in the middle. All right. Let's look at our unknown. All right. Again, it follows the words how many, what is. So you have to look for those keywords. All right. So the question is how many grams of Fe? All right. So let's look at our flow chart. Okay. So now, again, guys, once you have a box at the top row, you have to get one from the second row. So again, you have to get one box from the top and then one box from the bottom row. So let's go to the bottom row because that's where the unknowns are. Our unknown is grams. So let's look. Where is grams right here? It's right here. And that's going to be my new endpoint. All right. But wait a minute. Look closely. It says there unknown grams. What did I say if you ever see the word grams? Okay. Again, guys, if you ever see the word grams, you have to calculate the molar mass. Okay? You have to get the molar mass of whatever the compound, is that follows the word grams. In our case, it's Fe. All right. And again, you can just look for the book value for this one because I know for a fact you already know how to solve this. So, hey Google, what's the molar mass of Fe? Okay, so it's 55.8 grams of Fe. All right, cool. So now let's.
Atomic mass of iron is 55.84 atomic mass units.
All right, so there you go. She said it, 55.84. We're just going to round it off to 55.8. Okay, now let's go back to our flow chart and look at our steps. All right. Hey, this time, guys, the first step is the mole ratio. So you see this? To get from start to end, you have to follow two arrows, these two arrows right here. And they have to be in order, starting closest with the start. Okay, so this will be our first step. And our first step will be the mole ratio. And this will be our second step. Okay, all right. So those are two conversion factors. So let's put them in now. So again, you always start off with the given. Again, nothing goes here. And the given goes at the very top box, which is 2.5 moles of O2. Y'all see it? So again, that's our given, right? All right, so let's look at our conversion factor. So we need to add boxes, and this will be our first step. So our first conversion factor. So let's look. What does it say there in the arrow? Again, it says there mole ratio, and it has to come from the chemical equation, the coefficients. So I need to look for two things. O2, which is right here. Again, just read the given, and it's O2. So this is 3 moles of O2. And then read your unknown, Fe, which is way over there. Okay. And this is 4 moles Fe. And then you put in that column. All right. So this is our conversion factor right here. Okay. So we need to figure out which one goes on the top and which one goes at the bottom. So again, don't forget, guys, the one with the unknown formula always goes on the top. The one with the given formula always goes at the bottom. Since Fe is our unknown, our 4 moles of Fe has to go on the top. All right, you got it. So again, the unknown formula, the one with the unknown formula has to go on top, and the one with the given formula goes at the bottom. So the bottom will be 3 moles O2. All right, step one done. All right, so let's put a check mark on step one just to make sure we're done. Step one done, check. Okay, now let's do step two. So there's two steps again. So I need to add more boxes. I'm going to add more boxes. This will be the second step. Okay, all right, let's read what's in the second step. In the second step, it says there on top, molar mass of the unknown. So molar mass, and we just did that, is 55.8 grams of Fe. And what goes at the bottom? It says there 1 mole. 1 mole of who? Of course, it's the unknown rho, therefore it's the unknown. You see it? All right. So step two is done. All right. So now we set up step one and step two. So we're now good. Again, don't write down the first and second. It's just for me to label and for you to see it. Okay. And let's cancel out units. Again, everything will cancel except for the very last top box. If you did the conversion factors in order, everything should cancel except for the very last top box. So the moles O2 cancel out. The mole Fe cancels out. And you got 55.8 at the end. All right, at the last top box. All right, let's do our math. So I need to multiply everything at the top. Okay, multiply everything at the top. So, hey Google, 2.5 times 4 times 55.8.
2.5 times 4 times 55.8 is 558.
558. And the unit, guys, will be whatever's left behind. It's grams of Fe. Over. All right. So I need to multiply the bottom, which is just 3 and 1. So 3 times 1 is simply 3. Okay. And I need to divide 558 by 3. Hey Google. Hey Google. 558 divided by 3.
558 divided by 3 is 186.
Okay, so there's 186, and the unit is grams of Fe. And that is our final answer right there. Y'all see it? All right. So what should you have learned from this example? Okay, the first thing you should have learned is again the conversion factors. Okay, have to be placed in there in order. It has to be in order. Okay. What else? And that the final unit, the final answer, the unit of the final answer should be the unit in the very last top box. Okay, should be the unit in the very last top box because everything else should cancel out. All right. So go ahead. I want you to practice on all the other problems given in this PowerPoint. Okay. Also work on our sheet. Again, guys, please make use of the flowchart. Okay. The keyword there, guys, is practice, 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 practice. Please make sure that you work on the flowchart. And again, this should help you out solve stoichiometric problems. All right.